Hi, good afternoon, good evening, or good morning whenever you're watching this. Right now, we're working with my fifth period class. They're a really great group. I got some really smart people in here. So, they're going to be helping me out with today's lecture, okay? So, today's lecture is 2.9 Heterogeneous Mixtures. It's a topic that we kind of touched on Monday when we started talking about mixtures. But today, we're going to go in depth and we're going to see what the difference is between a homogeneous mixture and a heterogeneous mixture. And we're going to start by talking about this handful of jelly beans, okay? So, anybody, fifth period, Oscar, you want to help me out and read this paragraph really, really quick?
Yeah. Under what's the best way to eat?
Yes, sir. That little paragraph right there about the jelly beans.
Many people open the bag and eat all the candy, no matter what flavor each piece is. Others pick through the collection. They might say, I don't like the orange one, or maybe they just care for the lemon ones. There are different kinds of jelly beans in the mixture, and people will eat what they want and get rid of the rest.
What about you, Oscar? Are you a big jelly bean fan?
No, I don't like jelly beans.
Me either. I don't like jelly beans. Thank you,
No, they're
Oscar.
nasty.
Aren't they? They're bad. I don't know. They get stuck in my teeth, and I don't like it. So anytime when I was younger and I was going trick or treating, or even at a birthday party, and they gave out these jelly beans, that was the first thing that I threw out or gave away to my other cousins. And it's just me. I'm not a big fan of this type of candy. But if you are a fan of candy, like for instance, my husband, he likes all sorts of candy. He's chocoholic is what I call him, but he's not picky when it comes to eating, any type of substance, or whatever my mom cooks. um but if he is going to be eating, whether it's trail mix, jelly beans, or whatever, he doesn't really care. Like, he doesn't really start with a certain section or a part of what he's eating, like the jelly beans. Like, if he were to get a handful of jelly beans, I could totally see him just throwing a big, a couple in his mouth and not even looking at the color. But me, if I was forced to eat jelly beans, I'm probably going to lean more towards the orange and the pinks, because I think that just by looking at them, those are the fruity flavors, which is something that I like. I like orange flavored. I like, strawberry flavored candy. So I'm assuming that those jelly beans are going to be a lot more tastier than all the other colors. Okay. So as you can see, this mixture of jelly beans is uneven in the number of each flavor. Okay. So if you look at the flavors, and I'm just going to call them by color, you have a lot of orange ones. To be exact, you have 4 orange jelly beans. You got 4 white jelly beans. You got 3 pink ones that you can see. And then you can only see 1 green and 1 yellow. This is an uneven distribution in the amount of each color. This is definitely a heterogeneous mixture, and that's probably why it's part of our lecture today. So let's get started to the nitty gritty. This is the topic for the day: heterogeneous mixtures. Now, what is the actual definition of a heterogeneous mixture? It's a mixture in which the composition is not uniform throughout. And the first example they provide is vegetable soup. Vegetable soup is a heterogeneous mixture. Why? Because any spoonful of soup will contain different amounts of each vegetable. For example, if Alexia, I don't know, Alexia, I'm sure you eat vegetable soup. What's your favorite part of vegetable soup, girl?
Pues no sé, todo.
Todo te gusta, pero no te gusta, I don't know
about... como mi mamá en los caldos pues le echa apio, repollito, eso.
Right. Like, different people make different soups differently, right? Some people, they put chicken. Some people are just pure vegetables. A lot of people will put chicken and beef and vegetables. Like, there's a lot of ways that you can make it. But when you are pouring your soup, I don't know about you, but me, I like to eat a lot of the carrots and the corn. So if I can get a bunch of carrots and a bunch of corn in my soup, I'm gonna be great. Okay. And you'll probably see all the chunks of corn that are in there, right? And as well as my carrots. But the one thing that I don't really like to do is I don't like that liquid version of the soup. So yes, I will put a little bit of the water part, but you're not going to see it all the way full to the top, mostly because I'm always afraid to spill it somewhere, especially when I'm, going back and forth from the stove. But each spoonful will be different. Maybe Alexia likes the chicken part. So every time that she pours, she's going to make sure that she's got a little bit of chicken in each of her spoonfuls. For me, like I said, I'm probably going to put more. I'm going to be looking for those carrots. I'm like, where's the carrots? Pour it in. Where's the corn? Pour it in. So the amount of each vegetable will be different. I'm going to have a lot of carrots, a lot of corn, a little bit of chicken, and maybe a little bit of cauliflower and a little bit of zucchini, depending on what is in there, because that's not my favorite type of vegetable. All right. Now, the one thing that you need to know about heterogeneous mixtures is that they'll have what's known as something called a phase. Okay. And what is a phase? A phase is any part of a sample that has uniform composition and properties. Okay. By definition, a pure substance or a homogeneous mixture consists of a single phase. So let's go, and I want to look at this picture right here. I'm just going to push play because I need to make it bigger. Okay. Now, this is a homogeneous mixture, right? We know that we mixed up chocolate and milk or chocolate and water to make this cup of chocolate milk. Now, it has one phase because you can only see all the chocolate. It's all one color. It's all uniform. This is a homogeneous mixture with only one phase. The same thing would happen if you have lemonade, one phase, one color, even though it looks light on top, it's just the ice. Now, if you're talking about trail mix, like you see here on the top right corner, there's going to be different phases. How many phases do you see when you're talking about the chocolate, the raisins, and all of that stuff? How many phases do you guys see? How many can you count by just looking at it? Guys, anybody? So the raisins would be one phase. What's another phase that you see in this trail mix right here?
Las pasas, ¿no?
What is that? Is that the nuts, or is that the
Las cositas de moradas.
The M&Ms.
Oh, the M&Ms, the chocolate. That is definitely another phase of this trail mix. So you got the raisins, that's one phase. You got the M&Ms, another phase. You got the almonds, another phase. The cashews are another phase. And the last phase in here that I can see is the peanuts. Those are 5 phases, 5 parts that make up that trail mix. Okay? Everybody now sees the example they give us here, and they also tell you that heterogeneous mixtures will have more than 2 phases, or at least 2 or more. Another example they give us is oil and water, and they put it in this cup right here, in this martini cup. You can tell that the oil has a completely different phase in comparison to the water. Okay? And it doesn't matter how many times you mix it. Oscar, he's super strong. And if he would mix or shake this cup for an hour and let it just sit there after the hour, it's still going to go back into their phases because we know that they have different densities. They're totally different substances. So let's go back to the vegetable soup. If we were talking about that vegetable soup example, well, one phase would definitely be that water portion that my mom likes. Okay. In the water part of the soup, the liquid part of the soup, you're going to have the vitamins from some of those vegetables. You're going to have minerals provided by some of those vegetables. You're also going to have other components like You're going to have salt, pepper, whatever, consomme, whatever it is that your mom throws in there. My mom, she also throws some lemon juice in there. So all of that is going to be mixed in, and it's going to be mixed in evenly. Now, if you're just looking at the water from the soup, the liquid, that would be considered a homogeneous mixture. Why? Because all of those vitamins, all of those minerals, all of that salt, everything is spread out evenly in the water. But if you're looking at the other part of the soup, like the carrots, the peas, the corn, the chicken, the beef, the zucchini, whatever it is that your mom puts in her soup, everybody does it differently. The potatoes, all of those will be different phases of the soup. Okay. And most of the time, these vegetables, pues your mom's not going to count, okay, yo le voy a poner 50 or, 20 peas or 20 pieces of carrot, 20 pieces of corn. No, your mom's not going to do that. She's just going to be like, okay, pues I'm going to put this, I'm going to put this, y ya se hecho. And whatever you get in your bowl, Oscar, te lo vas a comer. Right? Mom's not going to say, oh, I need to make sure Oscar gets all of this chicken. I need to make sure that he gets his so much carrots and so much corn. No, that's not the way.
Yeah, that's what my mom does.
She makes sure that you get a little bit of everything.
Yeah.
But I'm sure that she's going to make sure that you get a lot of chicken, right? Because that's what's going to fill you up. That's when it's going to get you ready for that football game so that you're big and strong and you could hit those guys really, really hard and get that ball out. I don't know. Do you play offense or defense, Oscar?
I play offense.
Oh, you play offense. Okay, so you're always running. All right. Well, that's great. Either way, I'm sure you're a great athlete. There are a large number of heterogeneous mixtures all around us. Okay, so let's say you go outside. So I send Oscar outside, and he goes and he shovels some water and he puts it in front of me, and I'm like, okay, Oscar, this is a heterogeneous mixture. What are you gonna see, Oscar? What are you going to see in the dirt that you just shoveled from outside of your house? Can you tell me? What is
on the dirt?
Yeah, what would you see in the dirt if you were just to shovel it, bring it in front of you, and just look at what's in there? What would you see?
Like little animals.
Right, you're going to see little animals. You're going to probably see some roly-polies. You're going to see some earthworms. You're going to see some ants. You're going to see some rocks. What else are you going to see?
Different type of dirt.
Different type of dirt, definitely. You might see some regular sandy looking dirt, and then maybe your mom put some new fertilizer and you'll see that fertilizer type of dirt, right? Something else you're definitely going to see some grass in there, right? You're going to see some leaves that have fallen from the tree that's by your house. There's going to be a lot of different components, a lot of different phases to the soil. Okay, excellent. Thank you so much. Okay, so smog, they said, is another example, and they give us a nice picture, and this picture is of New York City and the smog. Look at that. How many of you have ever gone to a big city like Houston or Dallas and noticed like this little haze kind of fog looking stuff? I'm sure a lot of us have, right? Especially you guys, you migrants, you guys do a lot of traveling. So smog is another example of a heterogeneous mixture because first off, you can see that the smog is thicker in some places than the other, right? Here is supposed to be, I'm sure, Manhattan Island. Manhattan Island, you can't really see because the smog is so thick. There's so much of it. Now, what is smog? You have to remember that smog is a bunch of pollutions. It could be a mixture of water. It could be a mixture of burning gasoline, or it could even be some plastics mixed up with nitric oxide. And of course, you'll have some ozone in there. Now you can see that the way it spreads, well, it's going to be thicker in certain parts of the city where there is more pollution being produced, especially like in Houston. Like you could see the pollution, especially like in the early morning and like in the evening, right before sunset. you could see where the light is reflecting off of some of that smog. Okay. During the day, it's real bright. You probably won't see it as well, but it's definitely there. And Houston, it has a lot of oil companies and gas companies creating gas out of that oil. So they do give out a lot of pollution into the air. So that's one of the reasons why Houston will have a lot of smog around it. Right now, if you're looking at the news at California is burning, right? A lot of California is has a lot of wildfires. So those cities that are around it right now, they're covered in all of this ash and cloudiness, and we don't know the long term effect of that, of inhaling that much. So a lot of people are leaving California because of all of that smoke. So we already talked about this one. We saw it yesterday, and we already talked about, remember, different components, different amounts of different substances. Now here's another video. It's a little bit older. Let's check it out.
Welcome to Devon Middle School Radio. This is Mr. Pierce temporarily filling in for Matthew. This week we began our unit on pure substances and mixtures. We learned that there are two types of substances, homogeneous matter and heterogeneous. Homogeneous matter is described using one set of properties, while heterogeneous matter is described using more than one set of properties.
In other words, heterogeneous.
All right, so here's another example of a heterogeneous mixture. What do you see? How many phases do you see in this example? Anybody? Francisca, how many phases do you see? How many different types of substances are here?
The chocolate.
Definitely one phase. And then
the dough.
The dough is definitely two phases. Perfect.
This is when you look at something and you can see the different parts of the mixture. For example, a chocolate chip cookie. There's the cookie and the chocolate chips. Homogeneous is when you can look at something and only see one thing. It all looks the same. In the lab today, we're looking at orange juice, pop, and milk. We were trying to determine whether they were heterogeneous or homogeneous. We saw that orange juice was obviously heterogeneous because of all the pulp.
So that's it. Ugh. This is an example. If you look at orange juice under a microscope, this is what you'll probably see. And those little hairs, they're not really hairs. They look like hairs or fibers. They're really the pulp of the orange, okay? And you know the little pulps, the little bubbles of juice. That's basically what it is. At a little bit closer. Well, a lot closer, right?
Pop looks like homogeneous.
You can't even see it. I don't know why they included it in the video.
Yes, except for all the bubbles in it, which makes it heterogeneous. Milk looks like it's homogeneous because it's all white and you can only see one thing until we look at it under a microscope.
So here you have an example of regular milk on the right. This is the milk that you buy. It's probably whole milk. And then on the left, you have what's known as skim milk, okay? Now here you can see those little bitty dots. All those little dots are the fat that's inside of this milk. As you can see, once I turn the video back on, you'll notice that the skim milk is very, very smooth. It's not going to have all these little fat molecules that the whole milk has.
Then we can see all the fat. On the right, we can see all the globs of fat in the whole milk, but on the left, in the skim milk, we can't see any. The skim milk has no fat because they skim it all off to make it fat-free.
This is the DMS Radio signing off.
Thank you, DMS Radio. All right, so that's some more examples of heterogeneous versus homogeneous mixtures. Okay, so we talked about this one yesterday, but I kind of wanted to talk about the sources of some of these gases. Where did some of these gases come from? All right, so everybody take a deep breath of air. Okay, now And we talked about this yesterday, but I kind of want to talk about it again. So here you have exactly what you breathe in right now. So imagine if you lived in Los Angeles, you would not only have all of these molecules, but you're going to have a whole lot of pollution in there as well. Okay? But let's talk about just the molecules. The atoms, I don't really want to get into, but I do want to talk about methane, carbon dioxide, and some of these other molecules. So if you look here, here is your methane. Your formula is right here. You have 1 carbon, 4 hydrogens. Now, this is exactly what the molecule looks like at the atomic level. You have that giant carbon in the middle with 4 small hydrogens on each end. So methane, let's talk about methane. Methane is a main component of natural gas. This fossil fuel provides more than a fifth of the world's electricity. A lot of people, before, uh, still, even, I mean, my grandma's house, it runs on natural gas, okay? And it's just another way, another version of getting electricity. Some people think it's a little bit cheaper, but you have to think fossil fuels are not, we don't know how much fossil fuel we have on Earth. So we don't really want to consume everything so soon. So there are other sources of electricity. There's air, water, but this is just one. Now, if you're thinking about why is there so much methane in our atmosphere, you have to think livestock. And livestock, we're talking about animals like cows, sheep, and goats. And all of them provide a lot of methane. And how do they provide it? Well, it's because of their digestive process. They release this gas as flatulence, right? Everybody knows what flatulence is. It's a fart. They basically just like fart it out. Carbon dioxide is another molecule that you probably that you're breathing out right now. And what does it look like at the atomic level? You can see here that it kind of looks like one of those like toy balls that you use for your dog. You have, or even like one of those things that the baby kind of uses to chew on. So uh, what it looks like here is you have 1 carbon in the middle, that gray one right here, with 2 oxygens sitting on each end. Okay, and they're all about roughly the same size in comparison to when we talked about carbon versus hydrogen. Most of these are the same size. So carbon dioxide comes from a lot of sources, but especially humans. Every time that we breathe in our oxygen, we're going to be breathing out carbon dioxide. One thing that you have to remember about carbon dioxide is that it is a greenhouse gas, which means it will trap heat in our atmosphere and contribute to global warming. So us humans, we do our own part when it comes to global warming. Water, look at that water molecule. Water molecule, you got to remember, is always going to have 2 hydrogens and 1 oxygen. You got that big old hydrogen in the middle and the 2 little hydrogens at the end. It kind of has like a V shape, up or down. Water vapor is in the air and it's not visible. We know that unless it condenses to become a cloud. Now, how does it become a cloud? Water vapor will condense around the nucleus of particles such as dust, smoke, or salt crystals. And if you have a bunch of these droplets, like billions of them, they will come together and make those really nice clouds that you see in the sky. Hydrogen is a really, really small molecule. It is the lightest gas in our atmosphere. Okay. And what hydrogen was once used for, it was used to float. Basically, it was like a giant hot air balloon, and they would use it to take people back and forth, nice and slow. It's mostly like for the rich people who wanted to just show off. um, but you always have to remember that hydrogen is extremely flammable. So if you've never heard about it, the Hindenburg disaster was exactly that. It was a disaster. It was this hot air balloon ship caught on fire and exploded, and it was just horrible. Okay, if you want to know more about it, I would read up about it. And then you have oxygen. Oxygen is the main one that we are always concerned about because we always want to make sure that it's available, because if it's not available, well, neither are we, right? And then nitrogen, you have nitrogen we talked about yesterday. There's 78% of it in our air right now. All right. Questions, guys. Questions. All right. So let's close it up. In summary, a heterogeneous mixture is a mixture in which the composition is not uniform throughout. A phase is a layer or a part of your heterogeneous mixture. Your review questions. Define a heterogeneous mixture. We did that. It's highlighted. Why is vegetable soup a heterogeneous mixture? We talked about it, right? We talked about all the different phases in vegetable soup. And then how many phases are in a heterogeneous mixture? We totally highlighted that. So you should have that all in your notes. All right, guys. So you're going to have about 13 minutes left before you head on out. That's more than enough time to get all 3 of these done. Submit them. And those of you who owe me journals, start working on the journals. Okay? Questions, guys? All right. Thank you for being such